In this video, we're going to go over implicit differentiation. So in this topic, when you're dealing with implicit differentiation, you're differentiating the equation with respect to x. Let's say if you want to find the derivative of y squared with respect to x. This is going to be 2y times dy dx. If you want to find the derivative of, let's say, r to the third with respect to x, it's 3r squared times dr dx. If you want to find the derivative of x to the fourth with respect to x, this is going to be 4x cubed times dx over dx. So for implicit differentiation problems, whenever you're finding the derivative of a y variable, make sure you always add dy dx. But when you're differentiating something in terms of x, dx over dx will cancel, so you don't have to write anything next to it except this. So anytime you differentiate a y variable, make sure you add y prime or dy dx. So let's say if we want to find dy dx for this particular equation. So we're differentiating everything with respect to x. The derivative of x cubed is simply going to be 3x squared. Dx over dx will cancel, so we don't have to worry about it. The derivative of y to the third is 3y squared. Now we do need to add dy dx. This is what we're looking for. So for this particular section, anytime you differentiate a y variable, always add dy dx next to it. The derivative of a constant is 0. So now we need to isolate dy dx. Let's move 3x squared to the other side. On the left side it's positive, but on the right side it's going to be negative 3x squared. So to get dy dx by itself, we need to divide both sides by 3y squared. So dy dx, or y prime, is equal to negative x squared divided by y squared. We can cancel the 3's. So that's the answer. So how can we find the second derivative? How can we find d squared y dx squared? So since we have a fraction, we need to use the quotient rule. So we're going to say f is x squared and g is y squared. Well, f is going to be negative x squared. F prime, that's the derivative of negative x squared, that's negative 2x. G is the y squared, and g prime is going to be the derivative of y squared, which is 2y. And let's not forget dy dx. Now the formula for the quotient rule is gf prime minus fg prime divided by g squared. So g is y squared times f prime, which is negative 2x, minus f, which is negative x squared, times g prime, and g prime is 2y dy dx. All divided by g squared, which is y squared. So g is y squared, so g squared is y to the fourth. So that's equal to the second derivative. But we don't want to leave the answer like this. Typically, you want to replace dy dx, since we have it as part of the second derivative. And dy dx is negative x squared divided by y squared. So what we now have is negative 2x y squared. The two negative signs will become positive. So this is going to be plus 2x squared y if you combine this part. And then we can replace dy dx with negative x squared over y squared. And this is all divided by y to the fourth. So now let's simplify the expression that we have. So we can cancel a y variable. So on top we have negative 2x y squared plus, or minus, since we have the negative sign here. And then we have 2x to the fourth if you combine x squared and x squared. And we have 1 y left over on the bottom since we cancel 1. And this is divided by y to the fourth. So to get rid of this y variable, let's multiply y on the top and on the bottom. So on top, we need to distribute the y. Y times negative 2x y squared. That's going to be negative 2x y to the third. And y times this expression, the y's will cancel, and you simply will get negative 2x to the fourth. And on the bottom, y times y to the fourth is y to the fifth. So the final answer, we can take out a negative 2x, so it's going to be negative 2x times y cubed minus x cubed, or plus x cubed, I take that back, and divided by y to the fifth. So this is the second derivative of the function. Whenever you're looking for the second derivative for an implicit differentiation problem, make sure you plug in dy dx, because you'll have it as you get the first derivative. Here's another example you could try. Go ahead and find the derivative of x cubed minus xy plus y squared equals 4. Find the first derivative and the second derivative. Feel free to pause the video as you work it out. So the derivative of x cubed is 3x squared. Now what about for xy? So we got to use the product rule. So the derivative of f times g, according to the product rule, it's f prime g plus fg prime. So if f is x and g is y, f prime is the derivative of x, which is simply 1, and g is just y, plus f, which is simply x, and the derivative of y is 1 but times dy dx. Anytime you differentiate the y variable in implicit differentiation, always add dy dx. So we have negative, we need to distribute the negative sign, negative y plus x dy dx. Now we need to differentiate y squared. The derivative of y squared is 2y times dy dx. And the derivative of the constant 4 is simply 0. Now we need to isolate dy dx. But first, let's distribute the negative sign. So we have 3x squared minus y minus x dy dx plus 2y dy dx equals 0. Everything that does not have a dy dx, let's move it to the right side. So on the left, we have 2y dy dx minus x dy dx. And on the right side, negative y is going to become positive y. And the positive 3x squared, which is on the left side, will change to negative 3x squared on the right side. So what we need to do now, at this point, we need to factor the GCF on the left side, which is dy dx. So if we take out dy dx, we're going to have 2y minus x equals everything on the right side. So the last thing that we need to do is divide both sides by 2y minus x. So here's our final answer for the first derivative. dy dx is equal to y minus 3x squared divided by 2y minus x. So now at this point, now that we have the first derivative, we could find the second derivative. So we have to use the quotient rule again. So f is equal to everything we see in the numerator, which is y minus 3x squared. Therefore, f prime is going to be the derivative of y, which is dy dx, and the derivative of negative 3x squared is negative 6x. So g is what's on the bottom, that's 2y minus x, and g prime is going to be 2 dy over dx minus 1. So using the formula, the second derivative is going to be g f prime minus f g prime divided by g squared. So g, as we can see, it's 2y minus x. F prime is that. So f prime is dy dx minus 6x. And f is y minus 3x squared. And g prime is this stuff, 2 dy dx minus 1 divided by g squared, which is 2y minus x squared. The last thing that we need to do with this problem is we need to replace dy dx with y minus 3x squared over 2y minus x. We've got to insert it here. But I don't think it will be wise to simplify such a problem. It's going to take too long, so I will simply leave the answer like that. And that's going to be the second derivative. Now let's try another problem. Let's say if we have this problem, xy is equal to 4. Go ahead and find the first derivative for this function. So once again, whenever you see x and y together, you need to use the product rule. So f is x, which means f prime is 1. G is y, so g prime is dy dx. So the product rule is going to be f prime g plus f g prime. So f prime, that's 1. G is y plus f, which is x, and then g prime, that's 1 times dy dx. So that's the derivative of xy. The derivative of the constant 4 is 0. So now to isolate dy dx, let's move y from the left side to the right side. So on the right side, it's going to be negative y. And to isolate dy dx, we've got to divide both sides by x. So therefore, dy dx is equal to negative y over x. Now let's find a second derivative, since the fraction is not too bad. So f is going to be negative y. F prime is going to be negative 1 times dy dx. G is x, so g prime is 1. So now we need to use the quotient rule formula, so it's going to be g f prime minus f g prime over g squared. So g is x, f prime is negative 1 dy dx, minus f, which is negative y, and g prime is 1, divided by g squared, which is x squared. So now let's simplify the expression that we now have. We have negative x dy dx, negative y, that's plus y, divided by x squared. So now we need to replace dy dx with negative y over x. So the x variables will cancel. So what we now have for the second derivative is these two negative signs will become positive, so it's positive y plus the other y divided by x squared. So the second derivative is simply 2y over x squared for this problem. Now try this one. Let's say if you have the square root of x plus the square root of y, and it's equal to 9. Go ahead and just find the first derivative. Let's not worry about the second derivative. At this point, you have the general idea of what to do for the second derivative. Just make sure you plug in dy dx into it, and then simplify. So it's best to rewrite this equation as x to the 1/2 plus y to the 1/2 equals 9. So using the power rule, it's going to be 1 over 2 x to the minus half. And this is going to be 1 over 2 y to the minus half, but times dy dx. And this is equal to the derivative of a constant, which is 0. So let's take this term and let's move it to the other side. So on the left, we still have this expression, but on the right, it's going to be negative 1/2 x to the minus half. So at this point, let's multiply both sides by 2 to get rid of the fractions. So 1/2 times 2 is 1. So what we now have is y to the negative half dy dx is equal to negative x to the minus half. So now we could divide both sides by y to the negative half. So dy dx is equal to negative x to the negative 1/2 divided by y to the negative 1/2. Now what can we do to simplify that expression? How can we make the negative exponents positive? Right now, x is in a numerator. If we move it from the numerator to the denominator, the exponent will change from negative 1/2 to positive 1/2. So let's put x on the bottom. So now it's going to be positive 1/2. If we move y from the bottom to the top, it's going to be positive 1/2 as well. Now we still have the negative sign in front of it, so that's not going to change. X to the 1/2 is the same as the square root of x. So our final answer is dy dx is equal to the negative square root of y divided by the square root of x for the first derivative. Now let's work on some examples that have some trig functions in it. So let's say if we have this equation, cosine xy is equal to 1 plus sine of y. Go ahead and find dy dx. Go ahead and solve for it. Now, what is the derivative of cosine xy? How can we find that? The derivative of cosine of some function u is going to be negative sine of u times u prime. So we could see that u is what's inside of cosine. That's the angle of cosine, it's xy. U prime is the derivative of xy, so we have to use the product rule. To use the product rule, you need to differentiate the first part of the function. The derivative of x is 1. Leave the second part, which is just going to be y, plus keep the first part of the function, that's x, and then differentiate the second part, which is 1 times dy dx. So if x is f and y is g, this is f prime g, and then this is f g prime. So we differentiated x to get f prime, which is 1. G stayed the same. And then we kept f the same. And then g prime, the derivative of y is 1 dy dx. So you just have to use the product rule in that case. So to simplify it, we could say that u prime is y plus x dy dx. So used in this formula, the derivative of cosine u, or cosine xy, is going to be negative sine xy times the derivative of the inside, which is y plus, and let's make some space. So y plus x dy dx. On the right side, the derivative of the constant 1 is 0, and the derivative of sine y is going to be cosine of y times the derivative of the inside, which is 1 dy dx. So as we said before, the derivative of cosine u was negative sine u times u prime. The derivative of sine u is cosine u times u prime. So the derivative of sine y is cosine y times the derivative of y, which is 1 dy dx. So that's how we got this part of the equation. So now we need to isolate dy dx. So on the left side, let's distribute sine to y and x plus dy dx. So sine times y, that's simply going to be negative y sine xy. And negative sine times x dx, that's negative x dy dx sine xy. And that equals everything on the right side. So we need to get dy dx on one side of the equation. So let's take this term, which is negative on the left, and if we move it to the right, it's going to be positive. So on the left side, all we have is negative y sine xy. And on the right side, we now have x dy dx sine xy plus dy dx cosine y. At this point, we can isolate dy dx by factoring out the GCF, the greatest common factor. So the left side is going to be the same. Negative y sine xy. On the right side, we're going to take out dy dx. And so we'll be left with x sine xy plus cosine y. So to get dy dx, we need to divide both sides by this term. Once we do that, dy dx is going to equal our final answer, which is negative y sine xy divided by x sine xy plus cosine y. So this is the answer. That's how you could find the first derivative for this problem. Try this one. Sine x plus y is equal to 2x minus 2y. Go ahead and find the first derivative. Find dy dx. So the derivative of sine is cosine, and the inside part, the angle, is going to stay the same. And then we need to differentiate the angle. The derivative of x plus y is 1 plus the derivative of y, which is 1 dy dx. On the right side, the derivative of 2x is 2, and the derivative of 2y is 2 times dy dx. So let's distribute cosine. Cosine times 1 is simply cosine. And then cosine times dy dx, that's going to be dy dx cosine. Now we need to get dy dx by itself on one side. So what we're going to do is, let's move the negative 2 dy dx to the left side. So it's going to be positive. And let's take this term, which is positive on the left, move it to the right. And so it's going to be negative. So on the left side, we're going to have dy dx cosine x plus y, and then plus 2 dy dx. On the right side, it's going to be positive 2 minus cosine x plus y. So our next step is to factor dy dx. So now we need to isolate dy dx. We need to divide both sides by this part. The parentheses should end here, so this shouldn't be there. I closed it too soon. Hopefully you caught that. So our final answer, dy dx, is 2 minus cosine x plus y divided by what we see here. So divided by cosine x plus y plus 2. Now we can't cancel these terms because here we have positive 2 and negative cosine, and here's positive cosine, positive 2. If this was a negative 2, then the whole answer would be negative 1, but it's not. So this is the answer for this problem.